I just have it open in WordPad, or you can just open that little.
I have mine connected to RStudio, but because that's what I always use. That's not what I'm going to be doing it in, but that's normally what I use. I'll show you guys why I use it. But
Just select a program that once you say OK, it should your computer should remember that every time you put that kind of file. Well,
most of you guys, when you save your file and you're like, oh, I'm going to double click and open it, your computer's going to be like, no, what are you talking about? Don't worry about that. Just download the files that you have. So. Is anyone having trouble? Does anyone need help?
Where's that PowerPoint? Sorry.
It's in an email that I sent you. Are you on? Like this morning. No. That's why I'm telling you now. I'm letting you know. So the PowerPoint goes on for about 2 seconds, and then we're going into code. So part of what I sent you in the email is we've had some Mac users that have had success. And the second thing I sent you on how to try and get R Commander, which is that special program, and there's all kinds of things apparently that Macintosh wants you to do. And if you haven't done it, that's fine for today. It's just an easier version. We're actually not going to use R Commander. I'm going to teach you guys how to write code. But keep in mind that it's the easy way to do things. So as you're learning and you're trying to learn code, like that's your baby, right? That's what you want. Okay. Yay! So we're back. I'm excited. We've had a big breaky time. Has anyone been brave and like actually used R since we were last here? Emily's brave.
I guess I don't count. Sorry. Right now I have an unsolved bug in something.
Emily's brave to the point where she was like emailing me about random effects models. I'm just saying. That was brave. That was brave.
I'm between brave and insane.
I toyed around and tried to do stuff.
Good.
And I tried to look for all those different distributions you talked about. I tried to read up on them.
Yeah, the distributions are kind of fun for me and Nolan, Emily. I don't know how many other people are going to use them, but
I was able to talk to my mathematician husband. He understood what they were, but I just didn't know.
So is there anybody who still is busily downloading, or can we move forward?
Downloading what?
Just the code and the little script. Yep. So today we are going to talk about some basic ways that data is handled in R, right? It's a little bit different from what you're used to. It's object-oriented code. So we're going to spend a very good amount of time going through what these different things are and how you mess with them. And I've tried to give examples throughout the code, and I'll explain as we go along. And then I'm just going to show you sort of the one variable descriptive statistics that you guys would basically generally want to see, right? You want means, you want standard deviations, things like that, so you can check the normality of your variables. And then next time we're moving on to two variables, doing regressions, doing t-tests, ANOVAs, stuff like that. So that's our basic plan. We're taking it nice and slow because people who aren't used to writing code, this is probably going to be the scary class. But it's okay. You're good. You're good. R loves you, and don't panic. It's very, very important not to panic. So if you remember from last time, we had a few conversations about what different things are. So vectors are, think of like one variable, right? Just one column of data. A matrix beyond being a cool movie with special effects, has more than one variable, right? So if you think of like a two-dimensional thing, I mean, that's normally what we have. Like when you pull up your data in SPSS, that's what it looks like, right? You've got columns, you've got rows, you're good. Arrays are actually more than one matrix. So like sometimes we have multiple time points for the same people for longitudinal data. You can actually put that into an array. So it's like you're stacking one matrix behind another. The data frames are special because they can also have nominal vectors. That's things that are characters or strings. It depends on what program you're using and what they're called. They're words. It can include words. And lists can include varying lengths. So if you had, for some reason, somebody had 20 data points and another person had 10 data points and that wasn't considered missing data, you can actually put them together in lists. They're used more for getting information out of R. So when we start doing a bunch of fancy schmancy statistics and you're like, oh, how do I get the fit statistics for this? There are actually things that are contained within the programs that don't automatically output, but you can call them up. So we'll start doing a lot with lists next time. Okay? All right. That's the quick and dirty PowerPoint. Let's see some code. So when I go into my program, R Workshop 2, I have R Workshop 2. Whenever I double click on code, you can do the like select program from a list. It comes up in R Studio. And I'm just going to show this to you guys, and I'm going to go and pull it up in R, like the regular R. So R Studio, the reason why I use it, the reason why other people use it, is because it gives you the little color coding for your code that sometimes you can get used to. This SAS does this. I think SPSS started doing it. To where, green means I'm looking for a file. Blue goes for libraries. Then it also has this neat stuff over here where this is everything that we've pretty much been doing, right? So I can pull up old files. So if you think of like recently used documents when you're in like Microsoft Word or something like that, that's what that is. It's kind of your history. That's under files. And then plots, if you plotted something, will be there. All the packages that I have installed, it'll show right here along with all the other packages I can install. And then there's always our handy dandy little help file that's over there. And it basically does some really cool stuff. And you can expand up here where my little hand is, the code, or shrink it. And this is where the output will come out when you're looking at it. So if I just go, and run everything, this is everything we're doing today. What ends up coming up over here, these are all the objects that we're going to create, right? So they're in a little list over here. And I'll show you how to get to that in regular R as well. But if you have a big enough screen, if you have a very small computer screen, RStudio can be very frustrating, right? Because you can't see anything. But if you have a big screen, or you have dual screens, are always cool, then it can be really helpful in sort of like keeping you organized and being like, what do I have? What is going on? And at the end of this, we're also going to make this plot, so you can see like the histogram already comes up, right? So I can click back and forth, and it keeps you a little bit more organized. I like using it. It's just really what it comes down to. It also shows the entire history, so we've talked about saving your history and stuff like that. Make sense? Okay, but the way we're going to do it today is we're opening up regular R. This is not RStudio, this is regular R. So you're going to double click on your desktop or wherever your R is. I just noticed this morning that this version of R is called Roasted Marshmallows because they like to name it fun things. My nieces were roasting marshmallows last night. I was like, they're channeling my children. So typical, the console comes up, right? And then we have this command line, and this is where we write code, or we can write it in a script and then run it. Are we all remembering this? And we can also save this later, so if you're just messing around, you can end up saving all this code later, if you would like to do that. So we can go to File, Open Script, because that's what we're trying to open. Let me close RStudio, because it's not going to like that I have that open. Close. Don't save. Back. We're going to go Open Script. I am on my desktop. I am navigating to where my file is. And I conveniently see something called R Workshop 2. And you should too. Is everybody there? All right. And we say open. And the crowd goes wild. And everyone goes, yay, look, there's code. So one of the things that I like to do when I'm working within R that keeps my life organized is you can adjust your windows, right? So if I say Windows tile vertically, it just automatically puts them side by side. So I have two windows that are open. This is my script file, and this is my output, and it just stacked them like that. So I didn't have to sit there and click and like resize and click, just tile vertically, you're done. And life becomes a little bit easier. So the first thing that you guys want to do when you've opened up the script is change your working directory, right, to wherever you're working. This computer that I'm on the Family and Consumer Sciences computer, so that's my working directory, right? So set WD is your working directory. And that way, whatever we do today, you can just save it down into there and pull it back up later if you want. The other thing that you'll notice when I'm writing is the pound sign is the way you comment things out, right? So there are lots of little cat comments in this code. You guys all know I like pithy comments, so there's going to be lots of, oh no, what just happened? Oh wait, let's try this, because I do that. But that's the way you comment things out. So as we're going along and working through this and we're talking about it, you don't have to keep switching back and forth. You can just write your own comments and save this for yourself. That makes sense. Just hit the pound sign and make it happen. Okay.
It's like similar to the asterisk in the SAS.
Yes, just like the asterisk and SAS. So I just highlighted that code so I can set my working directory, and I hit Control-R, which means run. One of the confusing things about RStudio, if you get into it, Control-R doesn't actually run your code, it's Control-Enter. Except I think on Macs it's actually Control-R, which like, can somebody just figure out and just set it to what it needs to be? But it shows over here that it put that code over in what we were doing. There's no error terms, nothing gelling at me, so it seems like my working directory is okay. If your working directory is not okay, remember you need to use /. Right? So if you just copied a path from your Windows properties, it's going to be backslashes. You need to change them to /. Or else R doesn't know what you're doing. Are we good?
No, we need a minute.
Okay.
People like don't realize they need to change any of yours.
Exactly.
They're all using your code and getting
Exactly.
yours.
So we just need minutes to change.
That's okay. That's okay. Say again?
If you already put it where you're telling it to put it, it's going to give you an error code because mine's already there and it's saying, wait, error, but it's in there. I put it in there myself already. So that's why I think I got that. Does that make sense?
Yeah, it doesn't like the file name because you're setting a directory. So take
Right.
that file name off.
Take off the point R?
Take that. Nope, take that off too. You're saying look in this folder.
Just like that?
Like that.
Okay.
Now try and run that. There you go.
Cool.
Yeah.
There twice and it's
So you're saying what you're saying to R is for this session, go and look in this folder. So when I want to get a data file, go look in this folder. When I want to save something, just put it in this folder. So like Kaylee and I were talking earlier about like she has multiple projects that are going on. So at the top of her script, she would write the path file for whatever thing she was currently working on. And that way you can just keep it all in the same folder. And it makes your life a little bit easier.
Oh, okay, so that they should all be control gotcha. And then you like this. Well, then more stuff. Oh, I could just use one, no, not two there. Oh.
Oh, you're good. You got it. You're there. You're there. Is anybody else still getting error terms? Okay. Try.
Oh, maybe I
Try.
didn't.
Try these.
I bet I didn't
Yeah.
switch that one.
We're gonna try that. There you go.
Yay! Thank you for the magic.
Anyone else? Are we doing okay? Yes.
Pat, you look at yours.
So this is where I need to go. This is my path, but it's unrecognizable escape character string.
It's under C. I mean, it's easy as possible. Oh, C.
Do you see anything off in there?
So I eliminated.
I don't know. Let's try that.
When I say set my directory and I press return.
It won. No, it did it.
Oh,
It did it. It didn't do this one because it was backslashes, but you changed it. It did it for that one too.
It did. Okay.
It did. It's just scary when it gives you no response except like it just does. Yes, ma'am.
One response. Is that wrong?
I don't even know what you're doing now. So we're gonna go back to here.
That's a bad sign when Kat says that.
So you just have a folder on the C drive called R?
Yeah, C and then R. I tried to have minimal folders.
Okay.
Less to type then. Oh, I
So we're
forgot
gonna-
set, WD.
So yeah, so we're gonna type that here, right?
Super important.
The R underscore work. And you don't need that. You don't even need that thing. You're just setting your working directory. So this should work.
Okay, thanks,
Control
Kat.
Say you did on Max.
Yeah, it worked.
Say Command R.
Let's see.
Thanks, Kat.
Sure.
Because I think last time
You know what I'm doing? And if you want this, I can get it to you afterwards. I am creating everything she's telling us.
Yes.
Every step.
Can you send it to everyone? Would that be
Something. Where is?
No, I think.
Yeah, I would love it.
Where's my
Because I have
file?
these notes which are chicken scratch.
This is what I'm gonna do. I'll send it to you.
I'll save this handwritten.
Where's the script file?
Thank you, I
I
appreciate
saved
it.
it here in the actual.
Can you open the script file? There we go. Okay. So here
To your left column.
Okay.
I like your code.
Oh, you have to click
we're
on it.
here.
It should get you to
Control R.
get to your working directory.
How do I
this
see
to
it?
the
Is it
side?
like a staff file? Does it show up in my library?
No, let's try. No, I really hate
If you want to
Macintosh.
highlight this again, change this so this says your name, not hers.
Okay.
Change it to exactly that. And it's
Do you
a
want
text.
to save that?
I want to see.
Yes, because then if you
I want to see. I want to see the shortcuts for
you get the
running.
same thing going on here.
So
No, it's not correct. You have to change the code.
But control R, right?
Yeah.
Do I change it here or here?
Here, just go right in here
Okay.
and change it to read exactly like
What Kat said?
what
You
yours
should
says
be.
R
You should be
or your directory.
good.
See where it says
Can I copy?
I think you're okay.
It's saved in the file.
Okay. I think you're okay.
Can I go up here?
Okay.
Well, you may not have time right now, but that's what I do.
All right. We got this. We got this. Okay. So if you are reading in an SPSS or a SAS file, right? You need to open the foreign packages within your library. I just have it so that I'm reading in. We're back on that quine.txt. I told you it was coming back. We're reading it in as just a table.
We don't need to do the library foreign if we've already done it, or do we
You
highlight
don't.
that?
You only need to do that if you're doing read.spss or read.
Oh, okay, got it.
Read.table is part of the basic package of R. You can always read in a table. Everybody loves tables.
Error?
Some of us have one called Win Tab.
That should work too.
Okay.
I may need to rewrite my file because I need to go into my
Is your file in that working directory that you're in?
Win tab. I need to change it because there's
Okay.
some text. Got it.
He's got. Yeah.
Got text, is it got text?
Do you guys have Quine tab, which should also work? Do that.
So control R means, what's the meaning of control R? It's not a copy, it's like a,
It means run it.
it means run, thank you.
Run it. So whatever line you're on, it says run it. Okay. So when I do that, I don't know if it worked when you worked this way when you pull it in as tab, but I know when I pulled it in as text, it looks like I have the right file. This is part of the people that might run into problems. But when I go up to the top of my file to make sure that everything's okay, I see this funky thing, right? So this is drawing back in the last time we were here because we're about to figure out what went wrong. So I see V1, V2, V3. If R doesn't know what your variables are named, that's what it gives it, V1, V2. It gives it some funky name and order because it thinks that the first row is this, which means that somehow it got read in wrong. So the data set is there, but it's not exactly how we want it to be. The other way you can check and see if your data set is there is this ls parentheses, which is like give me a list of all the objects I have. Right? So one of our objects is called dataset1. So if you're thinking about what I showed you in RStudio, there was that whole list of objects that we're going to create. If we do ls at the end of it, that whole list of objects will come up. So the other thing that I can also ask for, which is the same, is objects. There's sort of like multiple ways to do everything in R. So I can ask for ls, I can ask for objects. Either way, a list of the objects that I have comes up. So it says dataset1 is there, but we went and looked up at the top, and we don't even like the way it looks.
But I'm not seeing it either. Mine's not doing that.
Yeah, it did.
I don't have all that. You have 126.7. I don't have that whole.
That's because you didn't ask it for dataset1. So if we just go, oops, you didn't run this line. So it's like, how do I know if it's there? Control R.
Oh, okay.
And it should do the whole thing. Right. So we read it in, and then we said we wanted to look at it. So to look at it, we just typed the name. Right? Mm-hmm. We typed in the name, which is dataset1.
Yes.
Then we said, is it in my list? So this is a way for you guys to figure out where everything is. So we don't like that V1, V2. Something went terribly wrong. We don't want it to happen.
Okay.
So our function that we read it in was called read.table, right? This was our function, read.table. So if I'm a new R user and I'm like, why is it doing this? This is really weird. I can do !, read.table, and it'll pull up something for me. The internet comes up, and it says read.table, blah, 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 blah. This looks wrong. The default is header equals false. Right? That's the second thing. So we know that we have headers. We have headers, we have variable names. So we just change that default on our next line of code. This is part of me helping you guys try to troubleshoot. So for dataset 2, which I think you have to change the quine.tab for you guys, but whatever. For dataset 2, we're setting to header equals true. So I just read in the same file and said header equals true, because the default is false. And when you do that, it should come up and look pretty.
Oh, you change it to dataset 2? Because I overwrote it.
You can overwrite dataset 1 if you want. I just put in
What I mean to say
dataset
is
2.
I said read dataset 1, but here it says dataset 2, and when I did that, I got an error. Dataset 2 not there.
Probably because you need to change this tab again. You guys have Quine tab, I have Quine text, it doesn't matter.
Sorry, Chad.
Yep.
We still having errors trying to read in our data set. So we have it, we have this, because you helped us. That's fine, right? Set. And then how do we do what Leslie did, which is read in data? We tried that, me and Henry, and we got
Where
an
did this
error.
LS come from?
Oh, did I type it in?
Yeah.
Okay.
That's why it doesn't like you. Now try it. There you go.
Oh.
It's there. Do you have an LS? You should have an LS now. You typed in that LS. That's okay, that's okay.
But Henry's is still not working. Okay, so set, this is what capture. Set WD and wherever it's located. Okay, and then, yeah, just like that. Does that work?
It's a special thing too, Max.
Oh, no.
It's fine. I think we just follow along.
No, Kat can help you. She's smart.
Well, we're, like, for the most part, we're going to be creating new ones.
Okay.
I'm just showing you guys something now. And we're coming back to this data set at the end. But for the most part, we're going to be typing in our own little vectors here. So are we all okay?
Yes.
Okay. So now when we read it in this way and say header equals true, we go back up and we see now we don't have this v1, v2, we have variable names that we had in before, right? So one of the things about R is you have to have a really good code book because remember it's case sensitive. So you have to know these variable names and if they're capitalized, if they're lowercase, like you have to be real specific because it will get very, very confused.
And if you were to do the read.spss, would it automatically have the labels, or would the default also be false?
I mean, we can look it up. So I think it probably reads in the labels. I might need to load the library first, though. Nope. Let me load the library. So I had to load, it didn't know what I was looking for. I had to load the foreign package. And read.spss. I think it automatically knows what you're doing. Because it doesn't have anything about not having headers. So because it's an SPSS file, it's going to take the variable names from SPSS. So, all right. So that's how we get things in. So then how do we look at things, right? Because if this is an easy data set. There's just, 7 different variables, stuff like that. But you guys know your data sets are huge. They're enormous. So you can call it up by the column number, right? So here I'm saying go to data set 2, then the brackets, right? And then it's always row, column, row, column. So I'm saying all rows by leaving the rows blank, and then a comma, and I want the first column, end brackets. So if I run that, it gives me from dataset 2, that was just our ID. Remember the first column was just your ID. So it's numbers from 1 to 146. This is right, this is not particularly surprising. These are all the ID numbers. So I said, give me column 1, and it just spit out column 1 for me. Does that make sense? We're going to keep going over like selecting out columns and selecting out different things throughout today as well.
Why would you want that?
You'll discover reasons why you want it. Okay, so hang on, just hang on. So then the next thing you can do, because sometimes like you don't know what column your variable is in, right? Half the time you don't know what column it's in. So I can say, I actually want this I want data set 2, is what I'm calling it, and then there's the $sign. So I'm saying there's a subsection of data set 2 that I want. What do I want? I want ID. When I do ID, which was I, capital D, when I do it with the lowercase d, this is the answer. I mean, you have my little commentary, but this is the answer R will give you, null. And you're like, what? It's like, it just doesn't exist. I'm just not going to talk to you anymore. Normally when I see nulls or I see errors or something like that, the first thing I do is I go check and make sure I've changed my backslashes to forward slashes. And then I check and make sure I have all my capitalization correct. And that I've ended my parentheses. Another reason I like using RStudio is because when you're writing code and you start a parentheses, it actually puts in the other end parentheses for you as you're writing along. So that's really sweet. So you don't end up being like, how many it just gets very, very confusing. So if I try it again with the correct capitalization, both uppercase, we see again this list of ID numbers. So if you know the names of your variables, you can always call up a variable and look at it and see what it looks like. Right? We can also call up different rows, right? So this is data set 2, and then it's again that bracket, and then the 7 gives me the 7th row. So if you want to pull up the data for one person, or usually it's people that are the rows, right? You want to pull up data for person number 7 because you think they might be a little bit funky. I say person number 7, and because the columns are blank, I'm saying give me all columns for person number 7. So it pulls up person number 7. They're saying that this is row 7, their ID number is 7, their ethnicity, their sex, their age, and the number of days they missed school or went to school, or I don't even remember what the data set is. But these are all of their variables, right? So you can pull this up. So then, other data manipulation things. So we have ways that we can pull out different parts of the variables, right? Let's say that we just wanted one thing that we're going to use that is just the number of days, whatever these number of days are, and I just want to put it in one simple thing. This is the object-oriented code. I am creating an object in R. My object is called X. And I'm saying with this little arrow, for most things you can use an equal sign, but nobody ever does that. Normally it's the arrow. So you're assigning to X, data set 2, the subset days.
Say that again one more time.
You're assigning to an object X. You're saying go to data set 2, take out the days, and put it into here. So it's like if you just wanted to take one variable or multiple variables and things like that. We're just learning like basically how to get through data in R. So if we do that, it's it ran, even though it doesn't tell you that it ran. And so I want to see this, right? So if I just type in X, because now I have an object called X, it pulled out all of the days. This is a list of all the days for the 146 people. Does that make sense?
So X is a new variable that you just created?
Yeah.
Okay.
It's not a variable, it's an object.
An object,
In other words, it's like a condensed, I think of it like copied it out of one thing and pasted it into another, so it's all by itself over there versus into all this other stuff.
Yep. And you were going to combine things into objects. You can pull things out of objects, but everything is about something named something that you want to do something to. Yes?
Do you even explain the concept of object in a way that might be familiar to SPSS and SAS users? Because I don't really know. I'm really not getting it, but I'm going to keep listening. Is it a separate data set? Like you know in SAS, like when you're creating new variables and you go to tab, like your variable's called cat and then I call cat2. Is it like X is cat2? It's like separate than cat. Cat still exists, but now with this I've created cat2, so I simultaneously have two different files.
Sort of, yes. Yes.
Okay.
That's similar to that. See, it's similar to that.
Variable, right? Emily's taught me that. That's fun.
Yep.
It's sort of similar.
So it's sort of similar to that.
Okay.
That would be the closest I think we could come.
I couldn't hear because it's all this cross. So I didn't hear what you said.
She was saying it's like if you want to subset something out in SAS and you have the cat data file and you subset out to cat2,
Right.
it's like having another.
Subset.
Well, but we're also going to be recombining. Bear with us. Bear with us.
I'm going to sustain my disbelief.
Bear with us. So we got a lot of code to go through. So, and I actually took some things out of today because I was like, oh, we got a lot to do. So one of the things about R is that R likes to know what type things are. So there's these things are called, this function is called is it numeric, right? So that's what I'm going to ask. I want to know, is days considered numeric? Because certain things you can do with numeric variables, certain things you can't. And we're going to do a lot of messing with factors and stuff like that. So I say, is X numeric? And it says, true. It is numeric, cat. Right? So let's try another one. Let's try Y. So I'm creating an object called Y. Y is the ethnicity variable from data set 2. Right? So I take an arrow and I say, you're going to have a new thing. This new thing's called Y. You're going to take from this data set just this column, just this F. And I could do that with those column numbers, but then you have to remember the column numbers. You're never going to do that. I'm going to take this F and I want you to put it into this for me. Right? So I think the F was like A or N, and I don't even remember what that means. But that's how it was designated. So it's letters was the ethnicity column. So if we do that, we can see Y. It is A and N. Y comes up, and this gives us all the different things. These people apparently were sorted by A's and N's. So this is the 146 different A's and N's for each person. And it tells you down here, what are your levels? Right? So sometimes if you have those undergrads typing stuff in, and they don't quite type in the strongly disagree, and it becomes strongly de-agree, then you'll see strongly de-agree down here. And you'll be like, oh no, something very bad just happened, right? So it can tell you where you are. If I ask R, is Y numeric, it says false. Because it knows that it's letters, right? And it put it in as a factor. It says this is a factor. This is going to become important when we're doing like multivariate regression. Like, is it a factor? Is it numeric? Is it like how is it being treated? So I'm going to ask it, is data set 2 numeric? And it says, no, it's not. Data set 2 is not numeric. Because is data set 2 a data frame? Yes. If you remember, data frames are matrices, look like matrices, but they have numbers and letters, right? And we have these variables in data set 2. And we have the days variable in data set 2. So it's treating it as a data frame. And then I say, well, what about Y? Y was this. Is Y a data frame? It says, no, it's not. So sometimes you guys are going to run into things, and we will get deeply into this in other workshops, but this is how you figure out, like, what did I read something in wrong? Did it not recognize that this was a factor? Did it read this as a factor, and I wanted it to read it as something that's more ordinal? I mean, people use Likert scales all the time and stuff like that, so we're going to be switching things back and forth. But that's just a way to sort of figure out where you are. So now we're to what is a vector, right? I think this was bullet point 1 on our slide, and we have an hour and 15 minutes. So what is a vector? Hey, I was here at 8 o'clock. I don't know where you guys were. A vector is, like we said, a list, right? It can be numbers, it can be words, it can be anything. So I created a vector called Z. It's another object. I'm saying, what is Z? Z is a column. That's what the C stands for. And in the column are these words, cat, comma, in quotation marks, is, comma, cool, period, and quotation marks, and parentheses. Right, so if we say Z is assigned as cat is cool, because we all know it to be true. Just ask my kid. And then I pull it up. It says I've got one column that says cat is cool. And it shows it in quotation marks to say I know these are letters. I know that these are not numbers. If I just want to pull out the first element of a vector, what I'm going to do, because I don't have the row column thing, right? There's only one column. So I say I want the first row. Show me the first row. The first row is cat. The third row is cool. And we can keep doing this over and over and over again. So you guys can remember like the up arrows, right? The up arrow gets you to where you were before. So if I up arrow this, I can just go cat, cool. Whoops. Cool. Cat, cool. You guys get the idea. Right on. So let's try something a little bit more real that would happen in real life. So these are scores for scales, right? There's scale 1, there's scale 2, there's scale 3. Each of these has a column. Normally you guys wouldn't even be typing this in, right? You'd be reading it in. But I just want you to see what R sees. So each of these is a column, and it's a series of 6 numbers. Another one is a column series of 6 numbers. You're just going to run that, and then we can look at scale 1 and scale 2 just to see that they're there. I mean, we know that they're there. So we pulled them in, and then we said spit back scale 1 just by typing the name of the object, and it said this is what I see for scale 1, which is what we typed in. We're like, we're good to go. This is scale 2, that's what we typed in. So we're good to go. So this is where we get into what things can be done. And this is sort of where we start diverging from what you do with SAS, because you would not do this with the cat dataset, cat2 dataset, right? I can tell R, and if I don't save something as an object, if I don't put it into something, what R does is it just displays it and then it's gone, right? So I'm saying I want you to combine scale 1, this one, and then square it. So when I do that, it spits it out for me. So it spit out the numbers, 1, 4, 7, 4, 5, 6, and then it squared them. 1, 16, 49. It's the square of all the numbers. And it just dropped it down in one column for me. This doesn't exist anywhere. When I close out of the program and I reopen it back up, it's gone. Like it's out in the ether. If I assign it to an object and I save my workspace, it's still there when I open it again, right? So if you can assign results to objects, you can assign, we're going to be assigning regressions to objects. Like we're going to be doing all sorts of things into objects so that we can keep track of stuff. But then this is just, other things that you can do. So I combine the two. You can take the sign of it. You can do the square root. I can add these two together. I can divide them and I can multiply them. I can basically do anything I want with them. Oh no. Except delete them. There we go. So this is the sign of it, this is the square root of it. This is, if you look at 1 plus 5 is 6, 4 plus 6, it's going down the columns and just adding it up. I can divide them by each other, I can multiply them by each other, and it's taking each column element and doing that together, right? The really cool thing is when you do matrix algebra. That's just fun. Only for you and me, though. And maybe Emily thinks it's cool, too. So, ma'am.
You said if you need to assign it to an object. Were those scales assigned to objects?
Yes. We created up here, we created scale 1 is an object.
Okay.
We said, take this column and put it into this object. The object is scale 1. And then we're moving the object around and doing things to it. But unless we save it, it doesn't do anything.
So this is probably a really dumb question.
That's okay.
Are these scales actually like data?
Oh no, this is me making stuff up for demonstration.
But I mean, they would be as if data?
As if data, yeah. as if data. So like for example, our next example, let's say that these are scores on a test. And if you get a 5 or higher, you pass. And if not, then you don't pass. Right? So those that might be things that you want to pull out. And eventually you'd actually, like a lot of what we do is we recode that into other variables, stuff like that. So I'm trying to show you guys how you can do things like this. So I'm going to say I want, I think if you get a 5 or higher, you win. So I want to make another object that I'm calling scale 1 win, because you win, right? I'm assigning something to it. And what I'm saying is anything in scale 1 that is greater than or equal to 5. So it's going to go through this whole list and tell me if it's true or not. So if you look at scale 1, we had 1, 4, 7, 4, 5, 6. Is that greater than 5? False. Is that greater than 5? Because it's a 4. And now we're on 7. 4, 5, 6. So these are sometimes things that people want to be able to do with scales, right? The other thing I can do now that I know false, false, true, false, 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 right? The other thing I might want to do is pull out all the scores where this is true. So if I do that, I say scale 1, and then pull out everything where this is true. So it pulled out these scores, 7, 5, 6. That's everything where it's true. If I want to say pull out everything where this is not true, I put an exclamation point in front of scale 1 win. So that means not true. So it pulled out all the scores 1, 4, 4 that were from our column that were not true. So this can be important when you're trying to like subdivide into groups. You know, like if you have male and female groups and you want to like take them and put them into separate objects, this can be an easy way to do that. Is that clear-ish? Mm-hmm. All right. What is a matrix? A matrix is 2 or more vectors, right? So if I wanted to take scale 1, 2, and 3 and turn them into a matrix, I want to sit there and put them, stack them up side by side and say what's going on, if these become people or they become different variables or whatever they become. The thing that you can't do is the first thing I do. You can't do this. You can't just add them up. Right? When I add them up, it's just adding, quite literally, down the rows. Right? It's adding up down the columns. That's all it's doing. So you can't do that. So what you end up saying is, I want to bind them together. I want you to take these separate objects and put them into one object. R-bind means row bind. Bind by rows. So let's see what happens when we do that. When I do R-bind for scale 1, scale 2, I want to bind all of these objects together. It took scale 1 and put it as one row. Scale 2 was another row. Scale 3 was another row. Now most of the data sets that I see, it's not like this, right? It's the variables are up top and this would be like the people along here. So the C bind here is bind columns together. So when you're doing R bind, you're saying treat these like they're rows and put them all in one big matrix. When you say C bind, you're saying treat them like they're columns and put them all in one big matrix. So when I do that, with the column bind, now the scale 1, this would be what we would think of, right? So scale 1's at the top. These are different people, possibly, things like that. So 1, 2, 3 are the variables across. Does that make sense? Now, if we wanted to put we can put them in any order that we want. So the next example is just that I can reverse these columns, and it doesn't really matter. It goes in whatever order I say that it goes in. So if I say scale 2, it puts scale 2. So you can put them in whatever order you want. So then, selecting things, when we selected things in a vector, we just needed the little brackets, right? To say like pick row 2, pick element 2. Here, we're back to that row column thing again. So if my thing is called Z1, and I want it to select row 2, so just these scores, then I just have 2, blank, and then you end it. So I'm saying pick that out. And when I do that, it spits it out for me. It took this row, it spit it right out. The other things that I can do are I can also ask it, what are the dimensions of my scale? Which is dim, dimensions. So it's telling me it's 6 rows, that's always rows, columns, 6 rows, 3 columns. So that way if you're pulling something in and you're like, did I lose data? You know, people need to check that. And if you're like me and you have millions of kids in your data set, then it gets really, really crazy. And you can just type in dim and life gets better. Does that make sense? Okay. So now I made something in order called Z2, just kind of back at a Z1 that we had. So I put these scales together in one big column, right? Which isn't normally how you would read it in. Normally, like if you were going to combine scales together, you do the column bind and stuff like that. But I did this example just like, what if you had one big column of data? One of the things I've done in R a lot is save posterior probabilities, and it comes out as just like this one big, enormous line of messiness. So you have to figure out what's going on. And so if I just had these in as one thing together, I don't have to go back to the original thing. I can tell it, I want you to make this a matrix. So that's what we're about to tell it. We want to turn this into a matrix. And the matrix that we're going to turn it into, we're saying assign a name. So these names are any name you want. I'm just making up names, right? So we're calling it my matrix. And this object is a matrix. This is a function. We're telling it, you make it a matrix. The matrix that we want is coming from this row called Z2, and I want it to have 3 columns. So if I try that, I could also say that's number of columns. I could also say n row, and that would work too. Then it gets me back to where I want to be. Does that make sense? I just told it, I want you to make me a matrix out of a big line of data, and I want it to be 3 columns. And then when I look at it, it looks like it should. Remember we had switched these. If we switch these back to scale 1 and scale 2, it exactly reproduces it, right?
So just to provide some context for people who are not you, or Emily, what we're doing is checking the data. Like we haven't run anything. We're just like verifying stuff, like checking stuff like dimensions, creating these matrices. Like this is all like data checking. It's like making sure, like you said, like the undergraduates entered stuff correctly. Is that's what all this is?
Yes, and because when we get into more advanced stuff, I don't want you guys not knowing this. Because we're going to be pulling stuff out and dropping into objects and messing with it. Okay. So understanding how to get to stuff in objects is going to become very important.
Okay. So it's not just checking your data. This comes into place when analyses are done as well? Okay.
Oh yeah. It's all going to be good times. So I can check the dimensions of my matrix, which are still 6 by 3. That makes me happy. I can also check the length of my matrix, which it tells me there's 18, right? So 6 times 3 is 18, so there's 18 total data points. I don't know why you would ever do that, but I figured you should have it in your code in case you need it. You can also ask it for dimension names. And it says null. It's one of those sad things. It's kind of like false, null. It's like, Kat, I don't know what you're talking about. So I want to assign some names to this. And we're going to act like my family's playing a game, which is part of the win column. So we play a series of family games every now and then. So I'm going to name my columns. And my columns are actually going to be different people, right? One of them is Kat, one of them is my daughter Emerson, one of them is my roommate Myrna. Then we're going to name our rows. The rows are game 1, game 2, game 3, game 4, game 5, game 6, because we have 6 of them. So these are how you name rows and columns, because you can do both of that, should you need to. So now when I ask for dimension names, it tells me dimension 1, which is rows, and this is dimension 2, which is columns. Dimension 1 has these names: game 1, game 2, game, et cetera, et cetera. So if you needed to call up and make sure that all of your variables got imported or that you didn't lose anything or things like that, you can call it up with dim names. And then you'll see what all your variable names are, if that helps you in any way.
So you mean if something got lost, like if you're merging files, for example? Okay.
Yeah, I mean, I've had people who thought that they gave me 3 waves of data, and I have 2.
Okay, and so this would check, like what you just, the
Yeah.
syntax or command language that you just used, that's how you could check.
It's basically like listing off every variable name that you have. So, all right, so now we've got my matrix. So these are all things on how to select things out in my matrix, right? When you have a matrix. If I want to just look at the whole thing, I can just type the name. The empty brackets are optional. You can just type the name of my matrix and it'll all come up. This is selecting the 4th row, all columns, right? I'm not in the right space on this, hold on. And let me tile vertically so I can do this, okay. So if I select the 4th row, it shows that my score was a 4, Emerson got a 3, and Myrna beat us all. She got a 9. If I want to know what our 4th game was. If I want the 4th row 2nd element, which is this row and Emerson, then I say 4, 2. Like that should seem fairly self-explanatory.
Using the word element, do you mean it's as synonymous with column?
Yes, except when you get into arrays, you're talking about you can have 5-dimensional space, 6-dimensional space. It's column in a matrix, yes. 1st element, 2nd element. So this was our 4th row, and we moved over 1, 2, and we asked for the 2nd element. That gives us a 3, right? Which is what we expected. Now, if I want to select multiple rows, but not all of the rows, right? I can ask for rows 1 through 3. That's what that little semicolon means. Colon means. So these are our scores for 1 through 3. Game 1, game 2, game 3. Yes?
This is kind of backing up, but if you just read in your data set, do you need to tell it, make it a matrix or make it an array in order to be doing these functions?
It should know, but if you remember the last time when we read in a data set, we had to go tell it was a data frame when it was a data frame. So that's how you can check with like, is data frame? And it says no, false. It's like, done with you. And you go back and say, make it a data frame, which I will show you when we get to data frames. Just to make sure that you guys have it all in one place. So if I want rows 1 through 3, I say 1 through 3, all columns. That's what my blank means. If I want columns 1 through 2, I leave the rows blank and then say 1, 2. If I wanted just columns 1 and 3, then I leave the rows blank and I say, give me, this little C means like the vector, right? Give me the vector of 1 and 3 in the column space here. I can say I want rows 1, 3, and 5. So we'll try some of these. This was columns 1 through 2. This is columns 1 and 3. I just want me versus Myrna. This is columns 1, 3, and this is all columns, rows 1, 3, and 5. Game 1, game 3, game 5. And this is how you assign things to elements, right? So let's say that my daughter got an infinite score on whatever game we're playing, because she's pretty smart, she's pretty good. So in game 4, right, which is our 4th row, second column is Emerson. She got infinity. So INF means infinity. So if you ever see that, you'll see it more in output when things are going very, very wrong. This is kind of like in Lizrel, when you get the thing that says like the fit is perfect, and you're like, oh no, you know, like something very bad happened. So you probably don't want to see this, but if you get INF, it's one of those things that you should be aware of, and that means infinity. So I assigned infinity to her score. I said change her score and make it infinity, and we'll see it in a minute. Then I said, you know, game 6, actually in the 6th row, we're just going to drop that game because I didn't do very well that game. Actually, I won that game. We're going to drop that game because I cheated, and it just shouldn't be counted because I'm a cheater. So we're taking row 6 and we are putting in not applicable. NA is how R says things are missing. Right? So when you read in things from SAS or SPSS, one of the things that it'll do is it'll take the missing values and make them all NA. So when you're reading in data also as well, like think really hard and look at the defaults for what they're doing with missing values. Right? Because usually you want missing values to be NA. So that's what it puts in is NA. And that's how they designate missing data. So if I look at my matrix now, my daughter got infinity on game 4 because she rocks, and then I cheated, so we dropped this game. It's considered missing data. Is that clear? So those are times when you'll see letters in with numbers, but it's not treating them like letters, or else it have little quotation marks around them. Like it thinks that this is something very specific, and the very specific thing it thinks is that it's infinity. All right. The other thing that you can do is leave out a row. So when I say my matrix, and instead of 2, like select row 2, if I say -2, that's leave out row 2, right? So we have all the games here except game 2 is gone, is disappeared. Clear-ish? Yes?
So,
ma'am.
So Kat, like is this syntax or what's this called? Command language? Doesn't matter?
I don't care.
So on the left side of our screen, when we're running these things, so you know, like when I did like my matrix 4, it showed me the output over here right away. But then when I did this one, my matrix 6, it just repeats what I typed, and then I have to type my matrix to see my output.
Right. So here, that's a very good question. So here, because it goes back to the object thing, right?
Okay.
Here, I'm telling it, show me this in my matrix. Okay. I'm not assigning it to an object. If I wanted to select out those and put it into like a separate data set, loosely termed separate data set, into another object, we would say, I would make it like my matrix 2, you know, and then the arrow, like take these elements from my matrix and put them into my matrix 2.
Like your infinity arrow,
the little arrow. Yep, like
arrow.
that arrow.
Okay.
Here, I said change something in here.
I see. So when you change something, that's then when you need the next command, which is your list command, like my matrix, right? Because like you've created something with your arrow,
right.
And then it just, if you do the control R, it just shows you that. But in order to see how your data has changed, you need to separately ask for my matrix or list. Or,
right.
I know not list, but
yeah.
whatever it is called above. Is that right?
Yes. So here you're doing something, but you're not changing the object.
Okay.
You're saying show me this, because you're not assigning it to something new.
Oh.
If you assign it to something new,
Okay.
then you have to ask to see that new thing if you want to see it.
Okay.
So here we change something in the matrix. And then everybody got deja vu. But we changed something in the matrix, and then we had to ask for my matrix again in order to see it. So when we pulled it up again, we could see the changes we had made. But on these lines, we're not asking to see something, we're asking to change something in an object. So this is why, like, we're going to be assigning a lot of things to objects because otherwise they're just gone. So if we close this out, the my matrix is still changed, but you're not going to see this. Why would you see this? You're just asking to see something. You're saying, let me look at this. If I wanted to select those out, I need to put them into something that I can later go back and mess with. So that's how this is like a little different from, this is when people start to freak, right? Because it's a little different from what you guys are used to doing. Yeah?
Just like, I'm going to do this, but typing in how we would save this as an object so we have it with this.
Okay, so let's say I wanted games 1, 3, and 5, right? So I'm here, so you guys can see. So here, when I ran this, I'm going to run it again. It just shows me these games 1, 3, and 5. That's all it's doing. It's not like it's saved this someplace. It's not like it's going someplace. I said, show me a picture. It said, here you go, Kat. If I thought that this was important and I wanted this someplace else and I wanted to be able to do something with it later, games 1, 3, and 5 are, you know, the games, then I would say, I need you to put this into something, and I need you to put this into games 1, 3, 5. So I took an arrow, I typed in a name, I made up a name. This is the name of my new object. I have an arrow, and I say put that in an object. When I run that, it's done it, but I can't see it, right? It says, okay, Kat, it's in an object. What do you want to do with your object now? Because if you think about all the things that you can run, a lot of times you don't want to see what it's doing. You don't want it to be spitting out a freaking matrix every single time on your screen. So you have to ask it if you want to see it. So now I want to see games 1, 3, 5. And there it is. So if I do a list of my objects, right, which we could do with ls parentheses here. If I do a list of my objects now, look at all my objects that I have, right? We've created data set 1. We've created data set 2. We have something called games 1, 3, 5 now. We have a my matrix. We had that scale 1, scale 2, scale 3, scale 1 win. Do you guys remember making that? There's an X, there's a Y, there's a Z, there's a Z1, there's a Z2. We've made all of these objects. So if I wanted to go back and call up Z2, it'll pull it right up for me and tell me what it is. I can stare at it. Is that making a little bit more sense now? Okay. So that's the difference between I just want you to show me something and I want you to put it somewhere for later. Yes?
Is there an easy way that if you want to remember what Z2 was, but not actually see the numbers, just remember what the command was, that you would see what that object, what the definition of that object was? Like if you just type in Z2, it's going to just bring up a whole row of numbers. If I want to remember what those numbers were.
Then I would comment your code as you're making it. That's what I would do. I write comments like, now I'm doing this, now I'm doing that. So the objects are important to remember, like when we get into things like regression. Like let's say that you run a regression. If you run a regression, it's just going to spit out the output, and it's just done. It's just like, peace, I'm done. If you put it into an object, you can call things out of the object. So this is why we're doing so much with this of like, how do we call things out? And why are we putting things in objects? So are we good? Yes?
In that example, you just said put the regression into an object. Do you mean the regression formula? Do you mean the output of the regression?
If you put a regression formula into an object and assign it to an object, it will save all of everything you could ever want.
Okay.
And I will show you how to pull it out. And be like, here, give this to me because I want to see it. Right? Including things you can do with diagnostics and stuff like that. It's cool. It's really cool. Just as cool.
But where is it saved? Like Katie's question is so helpful because like we just like created this, or Diana's questions, or both of them. So where is this? Are we leading up? Like where do I find this? I think that's where like we're all lost because where I'm lost. Because or we're gonna get to that, like you're gonna show us how to re-pull up these objects, or where are these objects?
You can re-pull up the objects by typing in the names.
So they're not like so all of this, like this new language that you just typed, this is still part of our workshop. Like this is part of the file. So like if I shut down my file, I just need to
if you shut down your file and save your workspace,
save my workspace,
right? It saves all your objects. So that's what we were talking about last time. You want to save your scripts and you want to save your workspace. So if I shut this down and save my workspace and I pull it back up and I type in Z1, it's going to spit out the columns.
Is it literally just save, or no, we're saving your workspace with something else?
It's literally file, save.
Save, not save as, just save.
Right.
So you just have to save your work.
Here we go. When I clicked on the console, I didn't think it was that. When I clicked on console, here it's doing the save the script, right?
Okay.
Because I'm over on the script here.
Okay.
Here I'm on the console. I say file, save workspace.
Oh, on your console. So
When you click on console.
So you can type over here, our console, save workspace. I see.
Yep.
Okay. And so that's how, like what you just typed for Katie and Diana will be saved. But if I just hit save over on the left, no, that would not have saved.
That was saving your script.
So which one's my script again?
The script is what we're typing in over here. This is sort of the output.
Script and output.
Right?
Script and output.
Only the things that I have to save.
But our output here also has a command line. But that's okay.
That doesn't reconcile with anything.
All right. Arrays. Let's talk about arrays. So arrays are two or more matrices, right? So if you think of one person who has a matrix of values, possibly the same variables over time. If you think of another person with the same matrix, another person, another person, another person, another person. That's what we're setting up here. So I created 4 objects called subject 1, subject 2, subject 3, subject 4. And here are their hastily entered scores, right? 1, 2, 3, 4, 5, 6, 7, 8, 9, whatever. And then I just ended up multiplying by 10 to make this, but that was simple enough. But each person has 2 columns, each person has 3 rows, and we want to stack these people up against each other because we want to do something fancy later on. So this is what an array is, right? To combine your matrices into one array, just like before, remember we had that command that was matrix? Remarkably here we have a command or a function called array. So we say, I'm going to create an object, and that object is called my array. I'm good with names. We had my matrix, now we have my array. The arrow, assign something, put something in here. What are you putting in here? You're putting in an array that's made up. There's that C again. You know, you're combining subject 1, subject 2, subject 3, subject 4. And I'm telling it specifically that my dimensions are, if you remember we had 3 rows, 2 columns, 4 subjects. 3 rows, 2 columns, 4 subjects. Or for some people this might be 4 time points. If you have participants and you're stacking it up by time. So just like with the matrix, remember when we told it the number of columns, we said give me 3 columns of this data, and then we checked and made sure it was true. That's what we're doing here, right? So if we do that, and we say, here's my array. So I just put it into an object, but it didn't do anything but just run it, right? So I can't see this yet. I put it someplace. But I can't see it because I put it someplace. If I ask for the dimensions, just to make sure, it says 3 rows, 2 columns, 4 matrices, essentially, stacked on each other. And if I look at it, this is what it does. And this is where things get scary, and don't cry, because it looks scary. It only really looks scary, right? So this was actually all rows, all columns. If you see this ... 1 up here, right? All rows, all columns for person number 1, because that was subject 1. And there's the rows and columns. All rows, all columns, person number 2. All rows, all columns, person number 3. So that's how you're doing the references. One thing I will never make you do is stuff that I have done with this, which is doing multivariate analyses using indices. We will just use packages and libraries, things like that. Make you want to cry. So I want to add some names to this because this is scaring me and I don't like it, right? I find this a little bit terrifying. So I am going to add something called dimension names, dim names, right? And I'm saying add names to the object, my array. It's a list, because it's just going to be a list of names. I want you to add this list of names for the dimensions, and we need to go in order, right? So the rows were time 1, time 2, time 3, because there were 3 rows, 2 columns, variable 1, variable 2. So I have the C in between there. I'm separating out so it knows that this is another element, like another dimension. And then here, the last one was subject 1, subject 2, subject 3, subject 4. Does that make sense? Yes.
C is always combine, or sometimes column, or
C means put these together.
combine.
Combine, connect. It's different from C bind, right? C bind means bind the columns together.
I see.
C means like I have a little list of something, a little vector for you, and I want you to apply this vector to this first element, and that was the rows. So that's what my rows are called. Yes?
If you had named the rows or columns in the matrix before, do those track along when you created your array, or do you have to rename?
They should have tracked. I'd have to try it though. They should have tracked. Where am I going? Tile vertically. So if I run this, and then I ask for my array again, like this is much less scary, right? It's time 1, time 2, time 3. It's repeating it for all of them. It's showing how it's putting together the array. So it's a little bit less terrifying. Does that make sense? Okay. All right, so if I want elements in an array, these are all the same thing, right? All rows, all columns, person number 2. I can also tell it, now that I have my labels, I want all rows, all columns for subject 2, in quotes, because that's what the label is. And I can compare that to where we brought this in from, which was subject 2. So these should all look the same, because we still have that object called subject 2 that we created. We created a matrix for this person and then combined it into an array. So they all look the same. Does that make sense? They should look the same. All right. So let's say that we can move on to data frames because they're probably what you're going to use the most. What is a data frame? We remember it has numbers and it has letters, it has all kinds of things. So we're going to add somebody to this game. My roomie's son, Areem, who likes to win. We're going to make a little list for him, a little vector, and we had 6 games, so we made him 6 games. But instead of doing the numbers, now we just have him win, lose, win, win, lose, win, lose, right? And then we're going to add that in a combine by columns, because we have the matrix that is Kat, Emerson, Myrna. We want to add a Areem to that. And we want to call it a new object, because we're going to mess it up, called my matrix 2. And then we're going to look at it. So when we do this, bad things happen. And I will tell you why. Oh no. So I added in this column that said win, lose, win, 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 because you guys are going to run into this, right? You have some people who have coded their freaking data with strongly disagree as one, some people who wrote in strongly disagree, some people, I mean, you've seen it, you've messed with it, it's horrible, it makes you want to cry. So this is what happened. Everything became a character. It said you added characters, everything became a character. Now these are no longer numbers. And you know it doesn't think they're numbers because now everything's in quotes. And you're like, what on earth? This is why we have data frames. It didn't know what to do with it, so it just made everything a character. Because you added in something to a matrix that was a matrix. And so it turned it into a character matrix. If you need to have things that are numeric and character, then you have to have a data frame. So that's what you need. So instead, we do something that makes a lot of sense. We're assigning a new object. I'm calling it my data frame, just so you guys can keep track of what's what. And we're saying put in this, my matrix. We're going to add in a ream, because we want in a ream column, and it's data.frame. So we had matrix as a function, we had array as a function, and now data.frame is a function. So I'm saying add that. Oops, where's my control? And now, it doesn't do that quotey thing. It understands that these are numbers. And it understands that these are numbers. And it's okay with that. It's cool. It's not going to yell at me anymore. So if I want to select things out in a data frame, I can just say, I want to see all the scores for cat. These are all the scores for cat, right? It's the same as what we were doing before. There's this little $sign here. This object, my data frame, select out the cat column. And it spit it right out for you. I can also say, I want to know what names there are in my data frame. So this is like dim names, but dim names won't work in a data frame. So this is just like, what variable names do I have? So it spit out all of us, because we're the variables in this one. And then I also can have this command called table. And I'm saying make a table of all the values from my data frame for a reams column. So I can see what his values are. He lost 3 of the games. He won 3 of the games. And it will summarize that up for you by using table. So these are just things that you may or may not ever use. Yes?
So just a quick question. Because it's now in a data frame format and likely we'll have huge data sets so that all of our variables can fit, is there a way to see your data frame as, kind of like a separate file like you do in SAS? You click on it and it opens up and it has like columns, rows.
Our commander likes to do that for you.
Is there a way to do that in
parentheses,
Oh, okay.
FIX,
And ours, okay.
and then the file name, and then pop it up in the middle.
Yep. Our studio sometimes doesn't like displaying data frames. It depends on the frame. So if we want to see a ream scores, just like we saw my scores, right? We have win, lose, win, win, win. This is just it spitting out his column. And it did that levels thing again. What are the levels that he had? The levels that he had were lose and win. Those are the only things we typed in were lose and win. If I had misspelled something and said lost and won, if somebody used lose and win, somebody used lost and won, it would add those down here too. And I'd be like, oh, I've got to combine those. So I'd know something was wrong. Does that make at all any sense for people? Clear up objects a little bit, what we're doing with them, why we have them somewhat? Yes? Okay. Can I show you some statistics? That's like what we actually do. So basic descriptive statistics, we're just going to go through some of these, and then I'm going to show you some of the things that you can get from different packages that are summarized. So this shouldn't take us long. So feel free to interrupt me as needed. We're going to create another little vector, just one little vector of data. We're calling it big X. There's big X.
Are you calling it a vector, not an object?
Well, it's an object. The object is big X, right? But it's just made up of one little column here. It's not a matrix. It's not an array. It's just one strip of data. Because that's all we're talking about is like how to look at one strip of data right now. So I can say, how many points do I have in that data? This is 11 long, right? So it's just adding up. There's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 values. And it's done. That's what length means. I can get the average by doing fancy things like adding up all my numbers and dividing by how many values I have. Or I can just ask it for the mean. And then my life gets a little bit easier. So if I want the mean of a variable, I can just say mean of X. Is that clear-ish? Yes. Okay. If I want the median, I ask for median. These are all fairly clear. Mode it doesn't like, and I don't know why. It doesn't like it because the value is numeric. Why wouldn't it like it because the value is numeric? Because maybe there's not one that is the mode. There's more than one. So you've got 2 2s, 2 9s, 2 7s, 2 4s, 2 6s, only 1 3. That's why it doesn't like mode. So the incomprehensible error message comes up that just says numeric. And when you have the whole big long string of it, you're like, I don't know why that doesn't happen, but okay. There is no most common one.
I don't think that's the error, because I put in a bunch of 6s and that didn't.
Are you sure?
Yeah.
Sure.
So if I go to do like mean parentheses, can I put a variable that we have in the data set, so for example, ID, sex, or age?
Yeah.
So when I do that, it says objects like age not found or object ID not found. So do I?
So you have to say dataset 2, $, age.
And then
No. It should work if we say, oh, age was actually not a number. Age was some sort of classifications. But days was a number. So let's try days. Ooh, oh wait, no. Let's try dataset 2 without a capital. So that's the mean of our dataset 2 days, right? So that's our object, that's our subset. I didn't like the age because if you look at the age variable, it's not like an age, it's like an age range. So that's partly why we're going to be messing with this data set more. It's because a lot of you guys have things that are rangy.
So unlike that, you always set up, you always need to parentheses for every data set.
Yes.
Or is that
Safest. That is the safest. That is safe bar.
We're all very proud. We're all very proud. So this isn't going to work as mode, is what you're saying? I don't know why mode's not working. So now we're going to ask a question, because this question came up. We're going to ask it about mode. I think it doesn't understand it as mode. So when I pulled this up, I think you're right. When I pull this up, it's saying that it's trying to set the type of an object, which isn't what we want. That's a very different mode. But some of the summary statistics that we're doing, which is what you type in anyway, like that you'll see, give you mode. And they should. Okay, let me get my other X back in. All right. So you can do the range. You can ask it for the variance. You can do all this separately. You can ask it for standard deviation. Now, when you guys are reporting things, this is something that you're actually going to end up using a lot. You know, you don't really want this like long thing, because then you have to remember what you're typing in, and then you have to round it yourself, and then you make mistakes. Am I rounding up? Am I rounding down? So you can tell it just to round the standard deviation of x to 2 decimal places. That's what that comment means. One of the fun things we're going to be doing later on too is creating awesome tables. It's like this. You can ask it for the minimum and the maximum. And I just put it into one little vector. I could have just said min x, max x. You don't have to do it all together. I can tell it to, I can ask it to sort x for me. So it took it and sorted it. It's all now descending. I can say, because the default for this is decreasing equals false if you look it up, so I can say I want it sorted by highest to lowest. Decreasing equals true. But the thing to note is that even though we've been displaying these different things, none of this has changed x. X is the same. So we're saying show it to me like this, but the object is still the same. If we had put an x in front of this sort, decreasing equals true, and our little arrow, now it's changed. Right? So is that starting to make sense as to when you're changing things and when you're just looking at stuff and you're just seeing things, and you're altering things? We also have fun things called summary. Give me a summary of x. Min, max, quartiles, medians. The psych package. Yes, sorry.
Sorry, just one quick question from a couple rows back. When you had the minimum x and maximum x, what does the C there mean?
I just put it into one little vector, so I could have just typed in, if I had typed in min x, that would have given me a 2. Max x. So I took the same thing. So this isn't, I'm just saying put it into one little thing for me.
So anytime you want more than one value to show up, that's C, like more than one command.
I was asking it for 2 things. I said give me the minimum and then give me the maximum. I could have typed in min x, and it would have just repeated the same 2. And I'm saying I want to see them together. I want to see them in one thing together. I want you to put them together into one little vector for me. Sure. So then some cool folk wrote the psych package for us, which are some commonly used social science statistics. So we're going to load that package by going to our library and saying pull out my little package called psych. It's just this library psych. And they have a cool function called describe. So I just asked it to describe x for me. And it says x is one variable. X has 11 rows in it. This is x's mean. This is x's standard deviation. This is the median. This is the trim mean. What's our MAD? It's supposed to be. What's our MAD? I'm gonna ask. Let's see what it is. The median absolute deviation from the median. I don't think I have ever used that statistic. Okay, that's what MAD is. The min, the max, the range. Then they have skewness, kurtosis, and standard error. So these are things that you want to be able to see. Yes, ma'am.
So when I did library psych, I got an error. There's no package, so that means I would have needed to download that package, right?
Yes.
The packages, just like you showed us last time.
Yes, but you should have. I thought you installed everything.
Must not have. I don't think we used psych library last time, did we?
No, we didn't use it, but it was on the list of like.
But that's where I would do it. And here
Yes.
packages.
So
Okay.
go to install packages.
Okay.
It's the median. It's the MAD, which is like apparently the median absolute deviation from the median. What does that even mean? Why would you use this? So you can scroll down and yep, just select California. Sure, why not? And it's saying what package, you just scroll down the psych. And then you'll have to, it'll install it for a minute, and then you need to say library psych. Okay, so we can also describe, this is something to note, right? This entire data set 2 that we had. So then it brings up every variable. And I do mean every variable. So ethnicity has a mean. I mean, who knew, right? There's a standard deviation. Why wouldn't there be one? It does warn you. It gives you these little asterisks. And it's like, I don't think you mean to be doing this. But it still gives you the answer. So just because the numbers come up, don't mean you should use them. And this is our telling you, these are the psych package people being like, I don't think these are numbers. I think these are actually factors. I think you've done something very strange here. So, but it will give you answers. I mean, there's a standard error for sex. Who knew? I mean, it's like, this is crazy. So it goes on and on. But that's one thing to keep in mind is that when you use describe, it will give you means for things it should never give you means for. So it has randomly assigned the A and N to a 1 and a 2, right? And when you looked at the levels, when we saw the levels for ethnicity, it said AN, so that's been assigned 1, 2. So if you want to know what's 1 and what's 2, it goes right across the row. 1, 2, 3. If there were multiple ones, it would just be going right across the row. And that's what it's doing. So be warned, be forewarned, be very forewarned. So these are our last little things. Are calculating a z-score, because that's something that we sometimes want to do. And I'm sure somebody's written a fancy function for this, but there's really no need because it's really not that hard, right? So we had a numeric variable called days, and the z-score of days, so I'm assigning it an object. I can put periods in here. People do that, so that's like, I know that this is days and I'm making it into a z. It's just a convention, but like you can name it anything you want. I'm creating an object called z-days, z.days. I'm taking from dataset 2, just the days variable. I am subtracting the mean of dataset 2, just the days variable, and I'm going to divide by the standard deviation of days. That's how you create a z-score, right? So when we do that and ask it to spit it back out, we say, give it back to us. So we can see. I did not hit Control R over here. I just hit R. Hold on. There we go. We can see that these look a lot like z-scores, right?
Can you just, oh, mine's all squished. But I mean, so that, what are the z-scores for which subjects? I mean, subject 1, 5, I mean, do you see what I mean?
So this is, we had 146 people in this data set. If we start, let me scroll up. This is person number 1, number 2, number 3. It's their standardized score. Right.
So it's just a little hard to
Yeah. So in mine, because of the way mine is, like it tells you for the rows how it goes 1, 4, 7. So this is person number 7, 8, 9. This is person number 10, 11, 12. So it's giving you a reference on the rows on like where you are. I mean, they just wrap and wrap and wrap.
Okay.
Things don't look pretty, like a lot of data sets just don't look pretty with an R. So then we can actually look at this, the probability under the normal curve if you wanted to, which are things that like nerds like me really like. And I applied that to the days. So you kind of know where it is, which I think only nerds like me would like. And the last thing is getting a histogram. So you just say histogram of X. I can say histogram of dataset 2, $, days, and it gives me another one, right? So you can at least have pretty pictures that you can look at. And of course, you can always do most of this simple descriptive data and stuff like that within R Commander through point and click. Yes?
So just a question about the Z days. That we just created like a new string of data or something. It's not in our data set yet. Is that right? We would need to go and put it, add it as a column into our data set too.
So we could take, if we wanted to have the column of days for dataset 2, and then we wanted to have Z days, right? This will be our little practice for the day. So we would say, we'll call it dataset 3. We're going to create a new object, and we're going to call it dataset 3, because I never overwrite into old things. That will send me into a crisis. I always create new things, but I'm just kind of like that, right? And we want to take it and make it a new column. So we want to C-bind them, which may not work. Actually, let's try it as DataFrame first, because that should work. So we have dataset 2, comma, and we're adding Z days. Something ran. It didn't yell at me. So if I want to know if I ran it right, I'm going to look up no caps, dataset 3. Now it has another column. And if I scroll back up to the top where the labels are here, it's called that column Z days.
It says Z score for days.
Yeah. I don't know why you'd want a Z score for days for this.
Show us how you could do it.
Yeah, I wanted to show you how you could do it. So. But you can also see here why the age thing didn't work. It's like F0, F1, like they're not number ages. They're range ages, letter ages. Okay. So we have about 10 more minutes if people have questions. Do people have questions? Yes?
When Bill and I were exploring some of the stuff, we were using AdHelp into like thousands and thousands of these columns, and like we couldn't scroll up. It was just like, I don't know if it's frozen or what, like does that happen? Or can you literally see the thousands of columns in the output window?
I would select out things to see.
We were just like pushing things. so I didn't know. I mean, we probably wouldn't do that essentially, but I just didn't know if it could handle it or if that was an error by us or like why it did that.
It's probably there. It's just that it hasn't displayed it. I mean, I've had millions of values come out. So like R is the thing that they use on the supercomputers because R can pretty much handle anything. So if it can handle CHKS, it can handle ad health. It's just that you can't see it. Like it stopped. Your screen isn't printing it out like that. Yeah.
Would there be a way to clear out like that screen?
I would save it to an object and then just select out like the first couple of rows to look at all the columns. You know, because there's no way you're going to go through ad health piece by piece and look at everything. So it's like using what we learned today, like what is it that you guys really wanted to see? Did you want to make sure that all the variables were there? Did you want to make sure all the people were there? You know, if you want to make sure all the people are there, then you can ask for the dimensions and it'll tell you how many people it has because it's going to tell you how many rows it has. If you want to know if all the variables are there, I would ask for the names and see what comes up and make sure that everything that you guys think is there is there. Especially because you're pulling out of the weights and stuff like that go along with ad health. It's complicated. Other questions? We had another question. Other questions? Are you guys totally terrified or are you feeling okay?
This is great.
Okay. So next time we're going to go into regressions. One of the quickie things on regressions and ANOVAs and t-tests and things like that. But just because I want to be able to show you something we have. What do we have in our thing? Let's see what we have. We have Z1 and Z2. That should work. Did you have a question? Because otherwise I'm just messing around. Do what?
What does LS stand for?
List. Give me a list of stuff. List of stuff.
Okay.
That's in there. I'm seeing if they're actually numeric. See, that should work. See, this is what happens when I try to like freewheel, and it's just not going to work. So I'm going to stop trying to do something that's going to be too complicated. I need to stop messing with it until I'm quite sure what I'm doing. Are there other questions? Yes.
Just talk about how, let's say, I saved my workspace and I want to come back to this in another day. So just talk about how to do that. 'Cause I just
Okay. Let's go click on our console and save what we've done for the day. So actually, I'm going to save my script first. So when I'm on my all the little black and whitey stuff over here, if I just click save, then it just saved to where it was, right? Because we opened it and now it's just saving it like you would normally save. If I'm on my console, I can save my workspace. I'm going to call this our workshop 2 console or workspace. So it says save image, right? I say no because I already saved it. So it asks you if you want to save when you leave. Now if I pull this up, the workshop 2, which doesn't like me because it doesn't know because it's not my computer. So I'm going to go to load workspace from within R. Go to desktop, R workshop. Which apparently is saving under an old extension, workspace. Stop it. Okay. Now if I type in ls, once I loaded up my workspace, that's everything we made today. It's there. It knows it's there. It's still there. So if you're thinking of this as like the little separate data sets, all the data sets are there. It knows that they're there. And it's pulled them all in.
So how do you start working with something, I guess?
You tell it what you want to do to it.
I just quit, and then I do load, and then what do I load?
You're gonna load. You want to load this.
The users?
Oh. No, this whole spiel that you just saved.
So I have to copy it like that?
Yeah, or you can point and click it, but if you
okay,
want.
let's point and click it just so I know how to do that.
So go to File, Load Workspace, and you probably you might have to change the files of type and go to All Files, and then find your R workspace. There it is. Open. It's there. Everything that you just did is still there.
That's good.
Yep. And keep in mind, especially for people who weren't here before, that if you've been just writing your script on the command lines and you haven't been saving it, that if you save your history, it saves all your script. Right? That's what it's doing. So there's a way to pull it out of. It's kind of like if you're an SPSS user, like pulling it out of the output because you've just been typing it in all along. But keep in mind, it will save all of your mistakes, all of your stuff, all of it. Everything that you just typed in will be saved. But just in case you're like, oh, why didn't I do that? Because that actually worked, you know. So you know, if you go through a whole series of steps or something, you haven't been writing it, and then running it and writing it and running it, and you've just been writing it and hitting enter, then you can still go back and save that.
So would you want to open your script differently or not? You start with your work and then worktop and then your script, or kind of like that?
It doesn't really matter.
Which way you go?
No.
I think this is a script file. Anything now?
Yeah, I think this right there. That's where you
This
were.
one here?
Yeah.
This one is it.
That should be it. You're there. You got this. So there are other questions, concerns?
If you go back,
Yes.
do you have to have your client tab file open if you wanted to reach back to, say, scale 3 or Z2?
No.
How's it all saved into you?
Because now it's an R object, right? So the client, what did we read that into? Do you remember? What did client? It got read in the data set too.
Client tab is what I have. Is that what you mean, Kat?
Right, but we read it into an object, right? The client tab, we read it into an object called dataset2. And there it is. So when I type in dataset2 and hit return, it says I'm here. Does that make sense? So you're not going and loading data. It's already an object. Once it's an object, as long as you're saving your workspace, it knows what it is. If you haven't saved your workspace, then you need to run your script again. If you haven't saved your workspace or your script, I cry for you. Okay? Because now you have to do it all over again.
So two things you're saving: your workspace where you run the console and your script. So you have two files. So it's like in everything else. You have a syntax file and a data file, right? Okay.
Well, it's like a syntax file and an everything file.
Everything file bigger than a syntax data
Yeah.
file. Okay. So there's a command line.
Yeah. Yep. Are there other questions? Thank you guys for coming. I'm enjoying this.